Hi all, once again welcome. So I can see many more have joined the session. So I really hope today's session will be interactive and you can grab so much knowledge from our CEO Venkat sir. So we'll look forward for that and within a short span of time we'll start the session. And I want everyone to be interactive. If you have any query, anything, you can just drop it in the chat box. Okay, so we have to make this really interesting session and it will be informative. We give you a surety from our side. So we need your cooperation also for that. Okay. Okay, so during the session, please be attentive and grasp as much knowledge you can grasp from our expertise, and please be attentive throughout the session. It will be really it will be beneficial for you people. I guarantee that, and be please attentive. Okay, so we'll start the session in a while. And so again, once again, I welcome you all. So we'll start the session. Good evening, everyone. So it gives me immense pleasure to extend to you a very warm welcome on behalf of Chipech Technologies, who has clubbed all of us together here today for the webinar on VLSI Career Opportunities for Students and Freshers. So before starting the session, let me introduce myself. I'm a DFT engineer working in Chipech Technologies, and I'll be initiating today's session. Okay, so that's about me. Now, to begin with, Chipech Technologies. Chipech Technologies was founded in October 2012 by Mr. Venkat Sunkara, the CEO, as a VLSI skill development company to bridge a gap between industry and academia. And over the years, Chipech has grown to provide comprehensive VLSI courses in digital and analog domains. And as we know, today Chipech is one of the leading VLSI industries that we already know that. So, about our CEO, Mr. Venkat Sunkara has over 23 plus years of experience in VLSI industry with a mix of design and application engineering experience. I welcome you, Venkat, for the session.
Thank you. Thank you, Nitika.
Okay. Next, COO, Prasad is also a part of this webinar today, who has experience of 20 years in operation management. I welcome you, Prasad, for the session.
Thank you.
So today, Venkat will be sharing his thoughts and industry experience on VLSI career opportunities with us. And once again, I welcome each and every one present over here for the session. And I now request Venkat to take over from here. And now over to you, Venkat.
Yeah, thank you, Nitika, for the nice introduction.
Thank you.
I hope I am audible to everyone. Prasad, am I audible?
Yeah.
Good evening to everyone. I don't know, so if it is a good time, evening, we felt many of you, since all of you are students and this session is intended for students, we kept evening. Though we know that evening may not be a good time, but considering your college work, college work morning to evening, we felt it is a good time. So we kept it at 6:30. So looks like that it may not be, that may not be, if that is not a right time for you, evening, right? So let's wait for others to join, and whoever have joined, I welcome each one of you. For the interest you have shown in knowing about this field, career opportunities, what is this field about, and so what are the career opportunities, what skills need to learn, and how can you pursue a career in VLSI. So I'll be definitely sharing my knowledge on that. And so in the meantime, let's wait for a few more minutes. In the meantime, before others to join, I would, as you can see, unlike your classroom, this is a platform where you cannot, unless you can raise your hand, but in this you can ask questions. Since it's a webinar, provision is provided for you to raise a question. There is a question box on the left side, and you can chat. If there is any problem, let us know in the chat window. saying that your audio is problem, you are not able to see the video, kind of. And there is a the in the end, of course, I'll try to throughout. I will check the question section, and feel free to ask whatever questions you have. And if that is not clarified, I will definitely look into it. But mostly, I'll try to clarify most of it. So hence, don't type the questions now itself, but wait, and towards the end you can ask, because I might cover all of them. So initially, while others join in the meantime, we'll give some more time. I'll try to understand more about you. As I was looking at some of you, they were, your registration details. I could see many of you there are people from second semester, second semester, third semester, BTech. Of course, some of them are, eighth also. There are few MTechs, but many are BTech students, and most of you are students. So that is good. So let me try to get a feel of. I mean, not exactly sure. Let me get a feel of. I will be running some poll. Help me with by filling the answers, so that I will understand more about you, and I can customize my talk according to your interest, according to your background or interest. So let me start with again. I don't know if most of you I'm assuming students, but not sure if any fresher who completed engineering or MTech, BTech or MTech joined also, or any professional joined. We don't know. So and let me help you understand about you first. So I'm starting this. So please answer whether you're a student or a fresher or a professional. I request everyone to participate. Okay. So I think, there are freshers. There are few professionals. So that is, but this is meant for fresh students only. Mainly the topic is designed for students. So there are professionals, it seems. I could see professionals. There are freshers. But fresher is okay, because, more or less it's the same category. But professionals, of course, since you can learn, but generally the topic will be more tuned towards the students. Still, please complete it so that we can move on to the next one. So mostly students, 69% students, 17% freshers, and few professionals. Let me go on to the next one. So if you are a fresher, then help me understand which course, BTech, MTech, others. Help me understand whether you are from a BTech or MTech or a MSc Electronics or something like that, or diploma. So mostly BTechs. Others also. Oh, that others I will be curious to know. Please type in chat. What is your other courses? Is it MSc? Is it diploma? Is it something else? Is it computer science in BTech or anything? Please type in chat, please. Oh, results. Okay, there are few others other than BTech and MTech. Surprisingly, no MTechs. Can I take it that no MTechs are there in this? Yes, there are few MTechs. I think maybe the timing is wrong. I mean, the evening, we're not sure. Do you think that evening is what do you think? Okay, so maybe I'll ask that separately. Because we have next 3 webinars lined up in the evening. I mean, there is one on physical design, one on design verification, one on DFT, all lined up in the evening. If it is not a good time, we will keep it in some other time. Okay. Thank you. So mostly BTechs. Now, if it is, what is your let me also understand your knowledge about VLSI. Some of you are, mentioned, different semesters, few are MTechs. Help me understand how much you know about VLSI. Do you know a little bit, or you don't know at all? But you are curious because it's one of the core domain. So help me understand, please. Okay, very good. No knowledge. Some are very basic. Perhaps basic, I mean, because you have a CMOS VLSI design, you have HDL. So maybe from a BTech subjects. Yeah, that's reasonable enough. Very strong. Few are very strong. So very strong people, can you type in the chat, please? What do you mean by very strong? I mean, of course, you took any special courses, you have done already some courses, like, while you are pursuing, that would help. Because their colleges are, as to the large extent, academic curriculum is giving a limited exposure on VLSI. Please. Okay, there are MSc Electronics. There are MSc Electronics. What do you mean by courses unavailable to download, sir? Okay, we'll come back to that. Now, what is your expectation from this? Expectation from this attending the webinar? Can you please write? Just write, so that way I'll understand, because when you are putting, taking your evening time to attend, it's better we know, and so that your time is valuable, and you learn something out of it. You get some useful information out of it. So, okay, so to gain, so as people are sharing, our screen is visible to you, and I request everyone to type why you have joined. It's okay, whatever, doesn't matter whatever you know and why you have joined. So to gain knowledge in VLSI, Bhavita, internship, to improve our knowledge in VLSI domain, to know much information regarding something about FPGAs. That's interesting. Only FPGAs. A guided path for a career in VLSI domain. Very good. Very good. I'm looking to know on VLSI and semiconductor industry. Okay, sure, I'll be covering that. I'll be covering the career paths. To know about VLSI and possible opportunities, I think this topic is, very relevant. I understand and appreciate. Then to know about career opportunities and ways to achieve a job and basic skills required. I think, exactly the way topic is designed to get a job. I mean, glad that you mentioned the skills required, right? Industry wants certain skills. Jobs are there, but skills are needed. A complete overview on VLSI and its opportunities. See, I'll try to, considering that we have scheduled hour and a half, we'll try to, obviously time is limited. I can't go everywhere. VLSI is a very vast subject, and so I try to go at a very high level without going into too much detail. Ranjit Kumar, to know about various VLSI domains. Sure, I think we'll be covering that. Career growth in VLSI. Career growth. See, also, I'm glad you mentioned about growth. Getting a job is easy. Sometimes, right, I'm seeing people from IT, people from certain domains where they come to us. I'm not seeing a career growth. I'm stuck. I'm not happy with the kind of job I'm doing. I want to switch to VLSI. So I think career growth matters. You need to choose a field which is exciting for you, which gives a growth opportunities. Step that will follow to get a job in VLSI. Well, ultimately, a job is needed, right? So how do we get a job? Knowing the best path, how to enter. What is the best path? I think I'll be talking about different options, how to get into VLSI. It could be a master's, it could be, a master's program in India, abroad. I will be talking about that. So mostly, I think more or less everyone is mentioning the same thing, right? Okay. Practical design concepts. Good, appreciate everyone. So now, proficiency, just give me one second. So how many of you want to pursue? See, knowing is something. Okay, you want to know information collection, right? But how many of you are interested or particular about pursuing a career in VLSI? So help me fill this question. How many are particular? Yeah, some are, you are very determined, some are not. That's okay. But you want to, just if you have some clarity on, if you want to, just fill it. You're wonderful. Maybe, yes, I appreciate maybe. Yeah, if it makes sense, only you should. Otherwise, shouldn't. That's okay. It should be no also. Perfect. Appreciate. So majority want to. Some are still, depending on if I get a better job in the campus, where I get a better offer from, maybe, latest technologies in the software or embedded, depends. So it's okay. So nothing is, People will go to management. People will go to different. The world is, there are a number of opportunities. Nothing should be limited. But I appreciate, yes, percentage and may. Okay, with that I understand. To a large extent, overall, right? Overall, thank you for that. Overall, most of you or all of you want to know about what is VLSI, what are the career opportunities, right? With that, let me go ahead now, and I have put things together. So let me go ahead and share. I believe you are able to see my screen. Can anyone confirm? Prasad, can you confirm?
Yeah, Venkat, we are able to see your screen.
Okay, great. So what I will do is, most of your questions might get answered. Don't type in the questions now, because what is the point if the questions already are answered. So towards the end, if your questions are not answered, you can ask. For now, by the way, I am not in Bangalore. I have traveled to a village, and there the connectivity issues could be there. I'm in a remote village. But I am managing. Hopefully, I will not have problems. But if at all any problems comes, you need to understand us and support with us. So please bear with me. But as of now, mostly we shouldn't see any issues. Thanks to the connectivity in village level also, and that thanks to the electronics people only, even for that communication, either now or during COVID. Without electronics, right? The connectivity, worldwide connectivity, work from home doesn't work. So that kind of strength or the role electronics has to play. So here is the agenda. What is the overview of VLSI industry? So feel free, in between, if you are not able to see, use your chat box. So team, the Tippage team, please monitor the chat if at all any issues, and call me if there are any problems, right? Otherwise, I will be assuming that things are fine and I will be going ahead. Okay. So overview of VLSI industry, chip design. What is the design flow? How design works? What kind of specializations are there? What are the trends in VLSI industry? I mean, in VLSI, unlike IT, right, it is always evolving, because these are, hardware design and manufacturing. Then we look at how VLSI opportunities, VLSI industries in India, and how to pursue a career. How are the job opportunities? I will be talking about that, and how to pursue a career in VLSI. Then we will have a question and answer in the end. For sure. So all your questions I will try to answer. So without wasting much time, I'll try to go into what is overview of VLSI industry. Okay. So electronics applications, right? Now electronics, as you know, is the backbone of the world, whole world. Without electronics, let's say if today electronics is not there, or electronic chips don't work, then a whole world stops. Maybe COVID stopped the external outside movement, but if electronics stops, everything stops. Everything stops today. No, so hence the electronic systems run 24/7 in the clouds, in the data centers, and all of that. Now, as simple as if the mobile network stops, our life literally gets paralyzed today. So this picture includes all the electronic gadgets that we use, starting from a mobile, of course, starting from a mobile laptop and a TV, then the networks, routers, servers, then you name anything. Electronics, without electronics, life is not there today. It has become too much, and it has become, dominant in every aspect. It has revolutionized the world, particularly last 2 decades. The mobile penetration has become so much, and last 1 decade, smartphone usage has penetrated so much, and it has opened up so much possibilities. And the advancement of AI and artificial intelligence has further expanding the scope of electronic systems. Hence, let's take the phone. I mean, let's take a typical one phone, and understand little more into what aspects comes under semiconductors in a phone. Let's say, right? Let's take an iPhone. let's take an iPhone and open. Tear down means typically there are people who analyze. So who analyze, tear down means there are vendors who open a phone and see which component came from which vendor. So the audio chips from Cirrus Logic, battery from Samsung. In iPhone, battery is from Samsung, camera is from Qualcomm and Sony, processor from Qualcomm. Nowadays, of course, iPhone seems to be making their own processor, but earlier they have their own processors. They are using Qualcomm processors. Glass screen, it's a mechanical part from Coring or some company. And if you look at it, right, so you have a mechanical parts, you have a glass, you have a chemical. Obviously battery is a chemical one. You have a memory in that, Toshiba and Samsung memories. You have a LCD screen, again a chemical one. LCD screen, it's a mechanical and chemical process, whatever. Touch screen controller, Broadcom, and Wi-Fi chip, Murata. So different, see, within a mobile, compact mobile, see how many semiconductor devices are there. See, whichever except here and there LCD screen or keyboard or touch screen or the package, remaining is memory related, processor related, and Wi-Fi. All these are semiconductor chips. So majority, a mobile or electronics product is majority dominated by chips today. Now let's dig into little more into the out of this iPhone. So, and out of this semiconductor chip, let's say we'll look into the processor, mobile processor in next few slides. Little understand what all it includes and all of that. So perhaps I will come to the so semiconductor industry is about a collection of companies engaged in the design and fabrication of semiconductor chips. So for example, Intel. So Intel only makes a processor, right? Intel, i5, i7, i7, that is laptop processors, and they have a server processors, Xeon and all other processors. So Intel is just makes chips, and their chips go into the laptops, their chips go into tablets, their chips go into the servers, data servers or data centers kind of. Similarly, AMD, they are competitors to each other. They both make the similar chips. Qualcomm, however, is a mobile-focused, processor maker, as you know, right? And we will look into that Snapdragon processor in next few minutes. How, little more details about Snapdragon processor of Qualcomm. NVIDIA graphics chips, which you all know, either your laptop, either NVIDIA graphics or what is the other graphics? NVIDIA and I'm trying to recollect who is the other one. Broadcom. I mean, the ATI was acquired by Broadcom. So typically graphic chip is nowadays people are using gaming. Then Broadcom. These are different. These are the semiconductor companies and they are product companies because that's a product. So semiconductors are essentially an enablers that power many of the cutting-edge digital devices we use today. As I was mentioning a few minutes back, right? Without semiconductors, life will be paralyzed. If you imagine, if you don't, your mobile suddenly don't work, you forgot the mobile at home or somewhere, will be literally stuck. In the semiconductor again, what is driving the change and what is the key component is MOS transistor. Yes, it is the transistor which is the cause for which is at the main component and the primary factor behind this rapid revolution. So it's accounts for the 99% of the all transistors. So once the MOSFET and it's miniaturized, and it's a scalable technology is driving the growth year on year, and and hence the bulk and hence year on year, right? If you look at, I'll come to the trends where I'll talk about year on year the rates of electronics always goes down. That should be a surprise. Why rate goes down year on year, and the complexity will increase. I'll come to that slide later. I think this Snapdragon, I'm going back to the mobile processor, a Snapdragon processor where this is the latest processor, 888 5G, 5th generation 5G Snapdragon processor. If you look at, right, this is developed by Qualcomm, and typically our mobiles, if you are not on iPhone, if you are using any of the Android, whichever you are using, either you will be using Snapdragon of Qualcomm or you will be using MediaTek. One of these processor will be there in your mobile, in your smartphone, right? So obviously it has so much advanced and complex features inside. As you see on the left side, connectivity. Connectivity. Of course, it's a mobile communication, 5G communication, wireless communication. It has to do, and it should have a modem, RF modem, because it's analog to digital, digital to analog. It has to happen, and those are the features at what frequency it will what frequency it will connect. Then the performance, what kind of processor are there, speed and graphics rendering. And in the performance, as you can see, 5 nanometer process technology. I think that is the key. So this is manufactured in 5 nanometer CMOS process technology. That is the one word you will be hearing in semiconductor: 7 nanometer, 5 nanometer. So the CMOS transistor channel length is a 5 nanometer. So the foundries which makes these chips process at 5 nanometer, right? So that is then security. Of course, nowadays security is a problem. So security, there are, of course, there are own solutions for security. Then of late, AI, artificial intelligence related engines are there. So Qualcomm, this processor has 6th gen Qualcomm AI engine, and and right side top gaming features. Obviously nowadays many of you are interested in gaming, and so it has a gaming related features also. Then the camera, we want multiple cameras, and the cameras are changing. Camera related features and technologies are changing, improving it every month on month, not year on year or year on year. That is also fine, but things are rapidly changing, more and more and better and better. Nowadays cameras, people started purchasing cameras. There were cameras earlier, and no more cameras, all mobile only. So this is about Snapdragon, where so many things, it has become so much complex. I was looking at, I think if you look at the gates inside this, I'm not going into too much detail. And if you look at this, this is around 10 billion transistors. 10 billion transistors, 1 billion to 10 billion transistors are there in a mobile processor. And if you hold it, it is a very thin chip. So, and typically now end-to-end design and development is done in Bangalore. For Snapdragon, the Qualcomm has offices in India, Bangalore, Hyderabad, Chennai, the Noida. They have the offices, but end-to-end, beginning to end, complete these Snapdragon chips are done in India. So I have friends, who work there. Even some of our alumni in the last 10 years, now many of them working at a lead level, senior level, at a different levels, including, managers also are working in a Snapdragon at Qualcomm. So these works happens in India. I mean, Intel, for that matter, not mobile, the portable laptop related processor, server process. I know many people at Intel. So earlier in our generation, 20 years back, we used to go to US to get these jobs. For last 2 decades, these jobs are available. And the last 10 years, all the chips are made in India only. So these are the technology nodes, CMOS process technology nodes. As you see, from 1970s to 1980, 10 years, how transistor, this shrinking, going down this, technology, right? Is the transistor size is shrinking. Transistor is becoming small and small. So transistor, I mean, again, the CMOS technology, between the channel, conducting channel between source and drain is becoming thin and thin because of the advancement of technology. That's what it means by shrinking, geometry or shrinking technology of the transistor. This is CMOS technology. Now we are in 2022, we are at 5 nanometer, 3 nanometer. Some are saying, currently a lot of things are happening at 7 and 5. 5 is more or less stabilized stabilized technology. So more and more, I will not. I will come to that later. I will come to that trends and how that will help. But this is how. So as technology changes, it brings an associated challenges also to solve. That's what VLSI engineers will be doing. So it brings a lot of challenges because the transistor has become so thin that you can't see this the whole chip itself. You can't see. I mean, it will be in a finger, your fingernail width of the chip. Whole chip itself is fingernail. Forget about it. You can't see the transistor at all. You have to use a microscope. Now let's see the design flow. Design flow, I mean, let's say if you have to make that Snapdragon processor here in India, of course they are doing it now. I'm already people talking about 6G. Somebody is talking about 6G. Always companies will be working at next generation. Let's say now 5G is already out, and they will be making improvements in 5G, and because in new features. So if you take any chip design flow, if you want to make a chip, let's see what will be the flow, what will be a typical flow, right? So a system architect proposes a new product and identifies what goes into software, what goes into hardware. So nowadays you cannot software or embedded and hardware, they are not isolated anymore, all are needed. So hardware and software has to interact each other in any product, right? So they will decide what goes into software, what goes into hardware. Then hardware team develops the microarchitecture. Then once the microarchitecture is available, then RTR design team will start coding it in Verilog or System Verilog nowadays. Then they do a verification. That's called functional verification or design verification, where they will verify, let's say if it is a 5G chip, they will verify if it is receiving 5G signals properly or not, whether it is converting to digital properly or not. From digital, the image processing is happening properly or not. If the audio and video is received properly or not. If there is any lapse or what. And nowadays you have so many features in a mobile, and every feature should be tested. And so every feature will be tested at a verification level, where the communication, data processing, storage, retrieval, and then so all these are verified. Verification is nothing but testing in a software. Verification in VLSI is nothing but testing in software. In software, people call it as a manual testing. They call automatic testing. So this is nothing but a testing. Later, once a verification is done, which means if it is working at a code level, so if there are bugs, they will work with the design team, and until bugs are fixed, they will keep on iterating between design and verification, design and testing. So they keep on iterating until bugs are fixed at a code level. Once it is working at a code level 100%, they will port to FPGA here. I think I haven't mentioned FPGA because this is ASIC flow. This is ASIC flow means FPGA is configurable. You can port it. If there is a problem, you go and configure it again, reconfigurable. So, but ASIC is not like that. I will come to what is ASIC in the next. ASIC is like let's say Snapdragon is a ASIC. They make 10 lakh chips in a foundry. Any bulk production happens in a ASIC. So FPGA, let's say ISRO for a satellite is only one piece or 5 pieces or 10 satellites. So wherever you have a small number of electronic application, FPGAs are used. Whenever you have a huge volume, 1 lakh, 10 lakh, anything, more than 1,000, not even 1,000, more than 10,000, then whenever there is a more number of units or chips are required, then they will go for ASIC for reducing the cost of chip. Because I'll come to that little later again. So typically they prove in FPGA level. If FPGA level it is working, then they'll go for ASIC, and then synthesis, physical design, physical verification, final layout, tape out. This is the ASIC process. But at FPGA level, mostly all this will be included in FPGA in one shot. If it is working on FPGA, they will use that FPGA in the certain defense applications, certain satellite applications kind of FPGAs. But ASICs, all mobiles, laptops, modems, any electronic application, toys. So software team parallelly develop the drivers, the application code, and this embedded team and software team, they develop these codes, and they port it to the chip, and let's say parallelly. But once a tape out means it will be sent to the foundry, and the foundry will send the fabricate it and send back. Chips comes back from the fab or foundry for onboard testing. So now you really test the hardware. You put the chip into the board, the way we have seen, right? Mobile board. Let's say we are talking about only mobile for now. So they will test on the board level, because chip means it's not FPGA. Chip means ASIC, application specific integrated chip circuit. Application specific integrated circuit. I'll come to that in next slide. Comes back from the fab for onboard testing. If it works, fine. If not, they will go for respin. If it works, fine. If not, they will go for bug fix, and send it again. But in ASIC, they can't afford. In FPGA, you can afford multiple rounds, but that is costly. I don't know how far you are able to understand this terminology. Bear with me, and we will clarify. So now, if you see this right in this flow, I will try to follow my cursor. Application specific integrated ASIC means application specific integrated circuit. So Snapdragon is a ASIC available for mobile applications, mobiles, for worldwide market. For Samsung uses Qualcomm chip, Oppo uses, or I don't depending on multiple mobiles uses Snapdragon process. So what Qualcomm does is they design and manufacture 10 lakhs chips and give supply to Samsung. Another 5 lakhs chips to Oppo. Maybe 5 lakhs chips to MI. So they will sell these chips to mobile manufacturers, mobile OEMs. So ASIC is application specific integrated circuit, and it is also called SoC, system on chip. Nowadays we are calling SoC when a processor is integrated with the memory and all other peripheral. Even nowadays everything is combined into one chip. Then it is called system on chip. System on a chip. So, so this is the terminology industry uses: SoC, ASIC, kind of for producing a chips in a volume where lakhs of units is called ASIC flow. So majority of the jobs in the industry are in ASIC flow, not in FPGA flow. FPGA is used by defense people, aerospace, defense, because their customers are very small. For missiles, for satellites, for certain defense application, they use FPGAs. But ASIC is a worldwide market. You produce it and you sell worldwide for all countries and all. And so let's say Samsung sells worldwide. Samsung will manufacture the chip and sells worldwide, right? So design specifications first, then they will make RTL description at HDL level. They code in Verilog or system Verilog. Then functional verification will be done. I think I've discussed in a previous slide. Then this is ASIC flow. Synthesis. From here starts the foundry related work, where you want to manufacture this, whether you want to manufacture the chip as TSMC, Taiwan Semiconductor Corporation, or Intel, or Samsung, or global foundries. Nowadays there are different foundries and very costly. So Samsung their own foundry, TSMC is the number one or leading foundry in Taiwan. So people will decide where to manufacture the chip. And that manufacturing related technology is 5 nanometer, 7 nanometer, which technology, which node. So that, and you have to make your design fabricatable at that foundry from this third step onward: synthesis, DFT, physical design. From it is a technology specific. Technology independent is at a code level, RTL level, Verilog level, system Verilog level. But once after that is done, the technology specific work starts, and too much complex. And these are all specializations in the industry. There are too many specializations. Each one is an engineer: RTL design engineer, synthesis engineer, physical design engineer, timing engineer, physical verification engineer, package and test engineer, functional verification engineer. Each one is an engineer. This many jobs are there. I will talk about that shortly in next slide. So I think little later. So the design abstraction, so let's say chip level, this is a module level, gate level, then the circuit level, then the device level. So ultimately your gate, your chip will be manufactured in a transistor level, PMOS, NMOS, in a CMOS fabrication level, it will be manufactured. But you will not work at that level. It is too complex to work. You will work at this system level. Then you will work at break that into module level, and you will module, let's say module, memory interface, analog to digital converter or digital to analog converter, or Wi-Fi chip or Bluetooth. So each one is a function, as you have seen in a Snapdragon. So you will work at a module level with the code. From then onwards, from here gate onwards, it starts the technology foundry specific, 5 nanometer, 5 nanometer, 7 nanometer, 5 nanometer. So this is a gate level representation. From here onwards comes the manufacturing technology. Then that gate will be represented will be in a PMOS and NMOS, which you already know how a gate is designed and, with a PMOS and NMOS. And that PMOS and NMOS will be fabricated like this in a device level. So, but you have to ensure that at a system level and module level, when you work, ultimately the design gets fabricated at this level, and you have to ensure all the related parameters are taken care and nothing will violate and fail in the process. And it still, when you get the chip from the foundry, it still works. So hence, here is the type of engineers, VLSI engineers in the digital flow, RTL design engineers. These are the core designers. These are the core designers who will design what component should be there in the new chip, whatever new chip is. This is called design engineering, core designing. So they code the design in Verilog or system Verilog. People are not using VHDL anymore. It's a mostly Verilog, system Verilog. System Verilog has more features. Nowadays, system Verilog is the next level of language. So these people I have already covered, hence I'll design verification engineer, DFT engineers. So this DFT, design for test engineers, will take care of not functional verification, design for testability. This talk more about manufacturing related defects. What if the chip is non-manufactured well, how do you detect defects in the manufacturing? Is a design for testability engineers. This is a testability, manufacturing defects testability. But design verification is functional testing. So I think we have a webinars coming up next 3 weeks. We have one webinar on design verification, one on DFT, one on physical design. Three different webinars are coming, which will cover more details and more the flow methodology about each of these. Because in this topic, it is too much for me to cover. Now, physical verification engineers. This is again more or less physical design only, but you work at following certain rules related to manufacturing. That's a physical verification. The STA engineers, there are different engineers in VLSI industry. If you search for these titles in Google, you will get. And analog flow, analog design engineers. Some of you, we keep seeing engineers, I am interested in analog circuit design. So this is analog design. Analog layout or custom layout engineers. Like, if you design a PLL, analog to digital converter, digital to analog converter. So you need, this is analog, custom, where, you're using sensors and all of that. You need analog in every chip for, generating clock and, and other things, RF signals for, communication signals, wireless. So you need analog chip in communication systems. So digital and analog will be there in any chip, most of the chips. But most of the part is digital. And hence more jobs are there in digital, very less jobs in analog in the VLSI industry. And there is analog and mixed signal. And these two will be interacting, and there are analogs and there are analog and mixed signal, design engineer, layout engineer. Design is about design, layout is all about manufacturing related in a particular foundry. Preparing your design to manufacture at a particular foundry is about layout. Nowadays, it's called physical design. It used to be called layout earlier. Less common types of VLSI engineer. Less common means not popular. You don't have a lakhs of jobs. You don't have thousands of jobs. You will have hundreds of jobs. Validation engineers, post-silicon validation engineers. You have thousands, but not 10,000 or 20,000, not like that. So you will have these are also engineers and working in different companies. Characterization engineer, library development engineer, CAD engineer, or flow development, automation using Python nowadays. They use Python and you develop flow in big companies, Intel, AMD, Qualcomm, any company. And EDA jobs. And Cadence, Synopsys, Mentor are called EDA companies. They are not VLSI companies. They are VLSI. EDA means tool developer, tools, softwares. They develop softwares for electronics industry or semiconductor industry. So other players will be there, but leaders, top three players are Cadence, Synopsys, Mentor. And you might have known Cadence, Mentor, or Synopsys. One of these you might have known in your college so far, which I'm assuming. Typically, the people who develop these softwares are called R&D engineers. So these are typically computer science institutes. They use smartness to develop the algorithms and all of that, very highly paid, very highly paid. And typically, ECE students don't go there. This is computer science students. And typically, these companies hire IITs and IITs only. Nothing less than that. They will not hire for these roles. Validation engineers, ECE students. Validation means similar to verification. Tool related, it's called validation. Tool verification or tool testing is nothing but validation engineers. ECE engineers does this. Application engineers, it's all ECE engineers game here. Pre-sales, post-sales. Pre-sales is before, post-sales. There are different, there's a lot of jobs here. There are a lot of jobs in application engineers with the ADA companies. And very well paid also, very well paid. Because these are MNC companies. Cadence, Synopsys, Mentor are MNC companies. Product engineers. Each tool or a software. In softwares in VLSI is called tools. Tools. That's called product engineer. No, the tools. So product engineer, for every tool or every product, there will be product engineers. I worked for your information, I think I worked for Cadence for a long time. I worked in Cadence US, Cadence India, and in India I worked in Cadence Noida office, Cadence Bangalore office. So I know how EDA works, how EDA and tool development, how they design the advanced, complex things. Why tools are very costly. So I like these three are very good companies. If you get a job in these companies, you better think about it because they're excellent companies. People work for 10, 20 years, 25 years. 10 years, less than 10 years are very few. Okay, so that's about types of engineers. I will come to that, I will come to this again later. So, now in the interest of time, I have to move on. So we'll say design process, higher levels of abstract and to lower levels of abstraction. What it means is you write at a code level, Rust is a technology, tool-driven work. That is what it means. EDA tools are used to automate the process, parts of the process. Use hierarchy to manage the complexity because nowadays when chips are becoming complex, and you divide the work into smaller blocks. Let's say Wi-Fi chip. Let's say memory interface. Let's say camera controller. Let's say DDR, the DDR controller. So these are the different, different design styles. These are little more about into design process, design time. Every chip, right? It's a details of the chip development now. So different design styles, state of design time, NRE cost, unit cost, performance or speed, power. These are the different design aspects which will be considered in the design and manufacturing of a chip. How much time it will take? Will it take 6 months? Will it take a year? And the non-recurring engineering cost is something where to make a mask at a foundry, at a Samsung foundry or TSMC, how much cost it will be? How much chip will cost overall? What is the frequency we can achieve? What is the power? How many milliwatts it will consume? So these are the different costs that will go into, and it will come into 50 million, 100 million, millions only, millions of dollars, not like, not like thousands or millions of dollars. So non-recurring means design is a one-time job, mask tooling. So because it's a manufacturing technology, CMOS fabrication technology, the mask has to be made, hence there is a cost. And depending on the volume, they will decide the unit cost. For technology, which technology will give less cost, that's what they will look into. And when it comes to performance, what is the frequency that the processor or chip will run, and how much power, because ultimately we want more backup of the battery, and what is the power supply, how do we reduce the power, increase the battery backup life. This is something designers will always very particular, and that's what differentiates between the one chip to another chip. So greater diversity. If you look at a chip, there are processors, there is software, there are memory, there is analog, and so hence there are more transistor doing different things. 1 billion transistors. 1 billion is doing different things in a say in a in a chip. And but you have to, let's say, in a mobile, every 3 months their window is very short. Every 3-4 months they have to release a new chip, and they are under extreme pressure. And the that puts a pressure on the VLSI. So VLSI is that way. Time is less, and their work schedules will be little tight. 9 to 5 job. It's not a 9 to 5 job. The people work 10-12 hours on an average. They work on evenings. They work on the night weekends. So work will be more. The pay will be more, but work also will be more. You have to use your smartness, and hence salaries also will be more. So trends in VLSI: smarter, faster, use less power. Always, right? You see, right? Year on year, we are having a better chips compared to earlier, and they are smaller, they are sleek, they are fast, they give you less power, and the interconnect between the chips is becoming less restive, faster and longer. Yield. How many yield is a different manufacturing related? This is more about manufacturing related. And for your information, right? Most of the manufacturing is done outside India, preferably in Asian countries. Taiwan is is managing majority of the manufacturing. After that, China, and some manufacturing is happening in US, etc. So India is trying to, as you know, Indian government is promoting to get the fabs and manufacturing happens in India. They're seeing some traction in the certain aspects, but I think things are looking very positive. So we can looking forward to have some fabs. Government has many incentives also there. These are the trends in VLSI. It's not one; it's a regular trends. Logic, every chip, more transistor and less space year on year. Clock frequency, the 1.5 gigahertz, 2 gigahertz, so by every year you will have a higher frequency, mobiles, and you have a less cost. More features, less cost is the advantage is the trends in electronics. Memory also, more memory in same space and less cost. So these are the typical trends, general trends. FinFETs is the technology for last from 7 nanometer onwards, where it's a fin in the conducting channel. There will be a pin process, and I'll not go into the details. So that itself will be a separate webinar. And but this is the technology, and it has a complexity. But currently, industry is using this. I think I would recommend to explore more on this. What is FinFET and how it works? In what way it is different, kind of. So I'll be skipping here and there in the interest of time. Some of these, Samsung, Intel, TSMC, these are some of the top companies. And top 1, 2, 3. These are top semiconductor companies in the world. See, Samsung is at the top. Intel, TSMC, Micron, Qualcomm, Nvidia, Broadcom, MediaTek, Texas Instruments, AMD, Infineon, Apple, ST, NXP, Analog. These are the semiconductor companies. All companies have their offices in India. That is good news, and which is good news for us for a jobs point of view. And global semiconductor sales, yes, in the right side, if you see, I think 2022, $542 billion is the worldwide semiconductor revenue. Accordingly, people invest, and accordingly, people have a job opportunities, right? So this is how electronics industry size. Electronics industry or electronic systems like mobiles, laptops, you name anything electronics, is a 1 trillion or more than. I think it's more than 1 trillion now. I think it will be multiple trillion, maybe 2-3 trillion or whatever. Out of that, semiconductor is more than 550 billion, and EDA, which makes the softwares to the semiconductors, is so our mobile as a unit considers under electronic systems. The processor, Snapdragon and processor chips comes under semiconductor. The Cadence, Mentor, Synopsys comes under EDA. So all the companies have their office in Bangalore or India, Chennai or some of the Indian cities. Mostly you name any company, they are there. And either they are service companies who offer services to semiconductor countries, or IPs, ARM, Rambus, Synopsys, Cadence. MNCs like Intel, AMD, Qualcomm. Product, Samsung and Apple are products. Product, I mean electronic products. Dell, HP are electronic products. EDA, Cadence, Synopsys, Mentor are EDA companies. The job opportunities in VLSI industry, the demand versus supply of skilled engineers. So that's always a problem which I'm seeing for 20 years. I'm in the industry now for 24 years. I'm always seeing that problem for last 24 years. Companies want skilled engineers. There's a scarcity, and the demand is there. Enough supply is not there. It's a perennial problem for the industry, and I'm part of the talent committee in the industry body. And talent committee need to work on the addressing this problem for the industry, because the industry has too many job openings if they are not finding people. And so demand experienced engineers continues, but supply gap continues. So MNCs hires contractors from service companies by paying in dollars. MNCs like Intel, Qualcomm, they pay the service companies like Wipro or HCL this many dollars, but they don't get not getting enough numbers. So opportunities, hence there is an opportunity for well-trained engineers. Not like I have a BTech degree, I have a MTech degree. MTech degree, BTech degree doesn't help. Do you have enough skill is the what they will look for. Majority of the hiring is done by service companies. Now service companies are HCL, Cerium, Tech Mahindra, Cerium, or nowadays many other Capgemini, Altran was acquired by Capgemini, L&T, and a little bit of TCS to some extent, Infosys and TCS presence in VLSI is very less. So how to pursue a career in VLSI, right? So campus placements, I'm coming to that point now. I believe now, I'm sure. So, I may be rushing now. The reason is I try to spend a little more, try to understand what is VLSI. Now, of course, you are more interested in how to pursue a career in VLSI, right? Maybe, so now let me complete this part. The campus placements in MNCs. So the one option is, if campus placements in MNCs are product companies, right? Now, so what are those MNCs are product companies? Intel, AMD, Qualcomm, Texas Instruments, Samsung. These are MNC product companies. Now, typically, these companies they hire as interns for freshers or interns, and then regularize for full-time jobs. They hire as interns, and then whoever is found to be good, they regularize into full-time. But whoever is not okay or they don't have openings, then the internship will close. But otherwise, they regularly hire interns. But typically they go to premium institutes, and typically masters they take, and IITs, NITs, triple IITs, VIT, Manipal, and many other. Maybe there are many other. I'm maybe not covering here, but there are many other where these university campuses, certain private colleges, PSG or and Amrita or many other colleges. So there are. I'm not saying that they're considered, if not tier 1, tier 2 colleges, or or tier 3. Their category varies. I'm not particular about that, but they go to from a premier institutes. And internship is the model, and whoever is found to be good, they regularize as a full time. So preferably, but then the MTech, you should have a good score and join in a good college, which has a good placements, and that is one way to go. So let's say you are an BTech, write a gate, get a good score, go to any of these premier institutes, and get a placement from the these product companies. That is one way, right? That is option number 1. Other option is, some of you want to pursue a master's in US or European universities, right? So you typically want to pursue higher studies in US. Yes, you can go there, but ultimately you will work in these companies only. There as an interns and then regularize. but the companies are same. Whether you join in India, whether you join there, company is same, work is same. But you will work in a US office or European office. But I think I would recommend US universities for VLSI. None of the European universities or 1 year courses and all that found to be not helping. I've seen many of them coming and doing a VLSI course again. Some of the 1 year MS programs in Europe. So if at all you want to do master, join in a good program which has a good university in US, which has a good campus connect also. Other option is campus placement into VLSI service companies. Service companies include HCL, Wipro, TCS, L&T, or Capgemini. These are the service companies. They will hire and they will put into a 4 to 6 months internal training. They don't call internship. It's a job. They hire you from the campus and they put you in internship. No internship, 6 months training. And then they'll put you into a projects, right? So this again, if you belong to tier 3, tier 4 colleges where hardware companies, VLSI companies or IT companies with the VLSI division, because HCL, Wipro, TCS, L&T, these anyway, they have IT, they have a VLSI also. So getting into VLSI division is one opportunity. They are hiring for that. That is one opportunity, right? That is also not happens, right? If no VLSI placement in your college, do a course with a placement assistant from VLSI training organization is next option. Because if it is not there, then you better learn something what is needed for the industry, either on your own or you join some course, which will help, because the institutes have a better connect with the companies, hiring companies, because companies prefer somebody trained. Even these companies are not preferring this because they have to invest in 4 to 6 months, or they are sending to us for training, and which is a cost to them. They are also, many of them, not preferring this. And hence, if you learn certain thing in the campus while you are pursuing studies, preferably rather than outside the campus, then you learn better. Then you have a higher chance to get into the placement. So job-oriented course, are typically 4 to 6 months. Typically 6 months. Some have a 4, 5, 6. Doesn't matter. Anywhere 4 to 6 months. Placement assistants, typically job-oriented VLSI courses with different training institutes in Bangalore, Hyderabad, or these places. So it will be 4 to 6 months. So the placement assistants. Salary range in VLSI is again typically, after training, depending on whether it's a service company or product company. If you have a master's and product company or MNCs hires, you will get it at 12 lakhs or more also. But if you are a service company, again, a small service company's hires, your salary will start anywhere between 3 to 4 lakhs. But then you will catch up over a period of time. You have to learn and prove and then catch up. So but entry is the key. Entry is the challenge in VLSI. Always I'm seeing for 20 years. You need to choose the right course as per your interest, and right organization or institute which has a better industry connect and better placements. So, and which one to choose, which course to choose. Let's say you have digital electronics, analog, and CMOS programming. You have different specialization, right? Who need to choose what is the right course for you, right? You may have this diet, whether it's physical design or so. If you are good in CMOS and transistor level, and you're strong in digital, strong in CMOS, and you're not good in logic. You are not logic means you are not good in programming. You don't like C, C++. You don't like Verilog and coding. If you don't like languages, if you are not a good programmer, then go for a physical design, tool oriented. This is a physical design. It talks about manufacturing related. It involves a lot of tool driven or software driven work. Then analog, both analog and layout and physical design, more or less this is the analog, that is digital. Both are layout or place and route. It's a fabrication related work. So analog even also equally provided if you are interested in analog side. Otherwise, design for testability is again a little logic and design oriented, but on the design side and the testability side related to manufacturing. Again, interesting specialization. No, if you are good in programming side, if you are good in C or C++, you like the protocols, you like the then design verification. What is not covered, this involves using the Verilog, system Verilog, UVM kind of little bit of programming for doing the verification. What is not covered is the design side. Side, RTL design, not many jobs are there, but there are some jobs. So RTL design is not included. That is a core design. Core design is not given typically for entry level work. It's a tool driven work is given, but not the core designing work. So these are the typical growth aspects where initially first 2 to 3 years is career growth. After that, your salary will grow much higher compared to a typical IT engineer. So VLSI salaries are much higher compared to a IT engineer. So if you look at the PD engineer, senior PD engineer, so you can look at those salary numbers. Typically, your growth will happen more or less after 3 years. The first 3 years, you should be prepared to learn, and your salaries may be on par with the IT. But third year onwards, your salaries will be little higher than the IT engineers or software engineers. So now I think that's about different specializations also. I think these are popular specializations in the market, and there may be other things also, but you don't. Those are not offered in a training institute level. They are trained in let's analog design. Very few jobs are there. Typically, they go for IITs and NITs. We have that course also, but we are not offering that anymore because of the less jobs in the market. So about ChipEdge, founded in 2012. It's been 10 years now. So many people are in analog, digital. We have both courses. We have many alumni now working in the industry, multiple learning models. We have digital and analog flow. Digital, you can see ASIC design, physical design, RTL design, low power design. So the analog side, we have both courses. Currently, we stopped offering analog. After COVID, we stopped offering. We all only have a digital flows, digital jobs, digital courses. We have a separate courses for students and freshers, working professionals. We have a courses on weekends. Corporates, many of the corporates use our courses. So over to Prasad now. Prasad, I will request maybe to complete walk through the courses, what kind of courses we have, and then we can look at the some question and answers. Over to Prasad now. Shall I transfer the control?
Yeah, Venkat, please. Thank you so much.
Can I transfer? You can walk through at your end. Yeah, I think I took more time,
Yeah.
though, and I tried to rush also, but I still took, already an hour passed. I think we need to, one option is we can take questions here, but other option is we can complete the remaining things also. So let me stop sharing. I stopped sharing. Now maybe Kunal can transfer the control to you. Any questions now, friends? Please type. Now you can start putting in the questions. So far, whatever I will answer after Prasad talks about. I think I'm realizing time is very less. Could have been more time because I try to give more inputs on the industry. Prasad, what shall we do?
Venkat, you can start answering the questions till the access is shifted to me.
Okay.
What I would suggest is
Okay,
there are
so-
already some questions in chats and question.
So now, please don't type in a chat section. Please type the questions in questions area. As claimed. So you got the control, Prasad?
Yeah, I got the control, and I will. Shall I share the screen or you will answer?
So please type the questions. Please type the questions in questions area. I'll try to answer. Questions area, please. If at all you typed in chats, please type in the questions area. I will try to answer. So far. Or can we get the recording of this session? Yes, the recording will be available in our website. We will communicate the recording a link once we post on the website. What after 1 nanometer? So I please post the questions in the question section, please. What after 1 nanometer? There's a lot of research is going on. Which direction industry will go after. 2 nanometer I heard. 1 nanometer I haven't heard because but what after 1 nanometer? What technology after 1 nanometer? There's a lot of research going on. I'm not sure. Can you send these contents with us? What is the priority level for MSc Electronics? Okay. So I'll come to the question section now. Please type in. Diploma completed, BTech pursuing. Yeah, nowadays engineers are available, right? Hence diploma, hence engineers are preferred. But 20, 15 years back, 10 years back, companies are preferring diploma. Good that you are doing BTech. How AI can help in semiconductor? Yes, companies are using AI in in the tool development and the chip development also. Yes, AI is needed or are being used in the chip developments. There are processes with AI driven chips also. How will be the hiring in VLSI in 2023 batch? That is a good question. The currently, though there is a recession concerns around 23, which is high likely in the market, global recession to some level. But the semiconductors, right, in the way we have seen in the COVID, during COVID and after COVID, the semiconductor demand has increased after COVID, and the demand is still not stabilized yet. There's still chip shortage, and new technologies have emerged, AI-based technologies, and a lot of compute, a lot of data center driven, more computing, because more apps and apps, all this has to run on the servers, right? So demand, though there is a currently little slowness now, but for next 3-4 years, demand visibility for VLSI companies is high. If you ask anyone in the VLSI industry, the visibility for next 3-4 years is strong. MSc Electronics can pursue VLSI, no problem, on par with BTech, but you need to learn something in VLSI. Which European countries are good to do MS? Ranjit Kumar, which European countries are good to do MS in VLSI? I am not sure much on that. Which European countries? Whatever I have seen in UK for 1 year course, they didn't learn much VLSI. I am not sure much about whether Germany. I heard is German universities are good, but I am not sure about much of the US universities. This contents video will be shared with you. This video will be shared, but not the PPT. Should we join a VLSI institute during our college Navia times or after completing my degree? If you are particular about pursuing VLSI, better learn something in the campus, because you will save time. Otherwise, you lose time of 6 months after the college. Now, if you do it during campus, not necessarily you join an institute. If you have something internally, if you have good faculty, or if not, some mechanism if you have, you can use that. If you don't have, yes, you can join whatever courses you like. But instead of after degree, if you during the degree, right, the advantage will be you can do your 8th semester project in the VLSI and you will save a lot of time. That's the advantage. And you can learn your VLSI subjects better. That's the advantage. Sir, I completed the physical design course in the Sheikhpuli, right? So currently, because typically November, December, hiring will be little slow. The companies, because of the recession concerns, they they're kind of a waiting, and typically January onwards hiring will restart. January onward. Generally, that is a typical trend. Is quantum communication having any relation to VLSI? Not much. I mean, any communication or whatever VLSI is about making a chips for any communication, any technology. It's a kind of, you see, VLSI is about making a chip rather than a transistor discrete component. So obviously, any electronics uses the VLSI. So communication technology may be different. When it comes to chip, it will be percentage. What is the percentage necessary for hiring in VLSI? 60 plus is minimum needed. 60 is the cutoff needed. Minimum percentage needed for VLSI. Which is better in VLSI and embedded? That is your choice. VLSI works at a chip level. Embedded has little more jobs than VLSI because it has a more applications than embedded board level, defense applications, aerospace, and embedded has a more applications and more jobs. But compared to salaries in VLSI is little more than the embedded. That you need to, and you need to understand your interest. What is your interest? If you like coding C++ and develop, device drivers, work on the, embedded, that is, you should definitely consider embedded. It depends on which one is passionate about. You should think which one is you passionate about. So RTL design, as you said, there are less jobs for RTL design. Then is it good to concentrate? So RTL design, core designing has comparatively less jobs. DFT, physical design and design verification are typically having more jobs. More jobs in design verification or physical design. Next is DFT, next is other things, layout, then analog layout, other things. Typically more jobs in design verification and physical design. RTL design cream work is not coming. So there is only tool related work. Is there any diploma course in VLSI? If so, there will be placement assistance. So there people call it as a certification course or diploma. Name could be different, but what they are covering, what is the job opportunities you need to look at. So some Tejo Krishna, I worked for 2 years in embedded testing domain, and unfortunately I have 2+ years of career gap. After that, I will have an opportunity. Yes, since you have embedded testing, you can continue in embedded if you want, or if you want to switch to VLSI, you can learn a course, but your embedded will be valued. Tejo Krishna. So your embedded experience will be valued. Yes, we have many people in the weekend place where people from the embedded background, FPGA background, IT background, teaching background does our courses on a weekend. You can choose a weekend and Tejo Krishna, and that should help. Is there a lot of pressure? Is there? Yes, pressure will be part of corporate roles, whether you like it or not. Money doesn't come easily. Lot of pressure means work, time-driven schedules will be there, and one should be on top of it. Can we switch from IT to VLSI industry? Shruti, yes. I mean, our weekend courses are the solutions for that. If you want to switch, we have regular that, while you continue, whoever are working, whoever have at least some experience, 6 months to 1 year are currently working, better do a weekend course with us. We are, doing for 10 years. We are leaders there. We have many people switch to VLSI using a weekend courses. I mean, that is an easy thing. I mean, this webinar is meant for students only. With that, I will take again over to Prasad now to walk through what kind of certification courses we have. Please help and walk through, in the interest of time. And then again, I'll take the questions. Can you go to full screen, please, Prasad?
Yeah, thank you. Thanks for that. And
Prasad, by the way, is a COO. He takes he's having 20+ years experience in different companies. So please, Prasad, briefly walk through what kind of verification certification course we have for students
yeah,
to learn something while they are continuing in campus.
yeah.
Or after campus. Go ahead, please.
Sure. Thank you so much. In the interest of time, I will try to complete few quick inputs that I wanted to share with all the attendees. The first, we have designed different courses for students and freshers. This will ensure that We train them from where your the curriculum which is there in the college is matched, and you learn the next step above, so that by the end, like Venkat said a few minutes back, will enable you more skilled and more industry ready, and deliver the best thing to the hired organizations. So, in with these things in mind, we have designed few courses in the coming days. First one is physical design, which we are planning to start on 19th of Jan 2023. The next one is design verification. These are exclusively for students. This is 30th of Jan 2023, and design for test, that would start on 8th of Feb. So, how will we train the students? It will be purely online sessions, and it would be 5 months duration. And in this 5 months duration, apart from the normal training stuff that we have, we also invite our industry experts to train you better and make you more industry ready on every Sunday. So that timing would be from 9:30 in the morning to 1 p.m. in the afternoon. So we also provide you the hands-on experience for live lab sessions, and lab trainer, the cheapest trainer, will train you for 3 days a week and every day from 5:30 to 6:30 on all the 3 days. And we also have, in case when you try doing some activities in the lab, you come across any doubts, you can always ask that. Various forums will be there, like WhatsApp, and some online forums will be there where you can post your questions, or you can also ask our trainer in between 5 p.m. to 5:30 p.m. on the 3 days of a week. So the lab access, every day 2 hours of lab access will be there for every student who will practice what he learned. If the training of the lab has been done for 1 hour, the access is for 2 hours, so that you practice well, because more and more practice will enable you to be more industry ready. So placement assistance, yes, we know that you are investing money and time to get these skills and ensure that you get placed well. So we understand that that is the basic thing, and to enable you to face the interviews properly, we also have the soft skill training and mock interviews to prepare you to face the real interviews with different companies. And the soft skill training what we have planned is also done by the corporate soft skill trainers, and mock interviews will be from the senior industry professionals who are already there in the VLSI domain, who usually take the interviews in different companies. Those kind of people will come and do the mock interview. So integrated internship, the internship is integrated with the course here. It is not only a course, we also provide the internship, and it has two different phases. First phase is of 4 months, where you will learn the domain knowledge, you will understand the concepts well, and you will be hands-on with the VLSI lab tools. And phase 2 is application, where we will give you a project which is industry relevant, and applications. This will enable you to start thinking on how to apply the skills that you have got, and you complete the project, and the trainers will support you in making the things understand much more better. So one of the project will be the part of your course itself. The second project is internship. So this is an integrated internship. So you will do the two projects here. First one is mandatory for certification. Second one is mandatory for internship letter. And the internships are not, there is no extra fees that we are going to charge from you for internship. It is free, and internship letter will be provided to you. So, virtual learning model, what we follow here, we will ensure that you get the hands-on lab sessions, whatever you learned, immediately followed by the lectures that you learned in the theory. You will be able to implement it practically. And closed group support, as we said, we have various forums like WhatsApp, email, tech groups, and all sessions will be recorded. This is very important, because in case if you miss out attending any session for any unavoidable situations, you can always go back and view those recordings and understand the concept well. This access will be there with you, and you can go back and view these recordings. So all the trainers who will be, the industry trainer who will be here, and the trainer who will be training from the chip edge end, they will be with 10 plus years of experience in industry and academia. And we use Synopsys tools, which who are market leaders. And course is designed by our industry experts who have more than 20 years of experience in the industry. And 70% of our course is on labs. This will enable you to have that hands-on experience on whatever you have learned. And placement assistance we provide with leading companies. They hire from chip edge. Many of the companies, more than 100 companies, are listed with us, who you regularly will be in touch with us for their various requirements. Basis their requirement and the eligibility criteria, we share our learners profile with them and enable them to face those interviews. But yes, interviews, you need to face them and ensure that you clear. We enable you to face the interviews more confidently. So we use Synopsys tools, as I said, and ICC2 is the market leader. So these are all the details about the tools that we have used, and in which you can see in the screen right now.
Yeah, I think the Prasad, to add a point on this.
Yeah.
These tools, these tools means the VLSI tools are very important for doing any in the course, whatever course you are doing. Whether you need to look at whether that company has a standard tools, industry tools, not cracked versions, not old versions, kind of. And do you get because tomorrow when you learn, when people look at what tools you have learned. So whether it is Cadence or Synopsys or which tools you have learned is what they will look at. For certain courses, certain domains, certain tools are popular. So the one of the standard is required. Whether the particularly for a physical design, when the Cadence and Synopsys for verification, anyone is fine. Because the verification is. So it depends on what domain, what tools are important. You need to check whether they have the latest tools or not. These are the tools that we use. Go ahead, please, Prasad.
Okay, thank you. Okay.
And they are very costly. Why VLSI courses are costly? The reason is these tools are very costly. That is the reason VLSI courses ending up being a costly. And these are not available just like that. They don't give. Yeah, go ahead, please.
Yeah. So now next is the certification and internship. The certification from chip edge technology will be provided to the people who meet the certification criteria. First is course completion has to be done, and which includes they need to attend the classes regularly, and they need to clear the assessments, and there is a final written test and the project assessment that would be given, that I covered in the previous one. And the grade will be given as per the performance, how you perform in the test. Though we will not share it to the companies hiring, but if they ask, we will share definitely. And the internship letter from the chip edge technologies will be issued to all the learners who complete the internship projects successfully. So who can join these courses? Who are all eligible to join, or who should go for that? BE BTech students in ECE, EEE, and instrumentation, telecom, who are in final year or in pre-final year, that is from 6th semester onwards, it is advisable that they can join the courses, so that by the, as Venkat said few minutes back, the final year projects can be on the VLSI, which can be feather in the crown. So probably that could be seen in that way. And MTech students can also go for this with the specializations like VLSI embedded and power electronics, communication, etc. And fresh graduates who have completed their graduation and who have completed BTech, MTech in 2021 or 2022, they are also there. And someone has posted this question, and Venkat has already answered it. Even I put a text there. MSc Electronics final year students and fresher can also do this course.
Okay, any questions now? Any pending question? Please post in the question section, please, rather than a chat. So one question from, I think, Santosh is, after completing the course from placement, after completing the course for placement, product-based companies comes and average package. Yeah. So the product-based companies I already mentioned, that majority of the hiring they do from IITs, NITs, and some next premium institutes. However, certain companies, right? Let's say Synopsys, Cadence, Intel, some of these companies, sometimes Samsung, not consistently, but the way they do hire consistently from premium institutes, but they do hire even MediaTek, Synopsys, these, and hire regularly from us. And when they get selected, but they're very particular about, they preferably go for ask for master students. MediaTek doesn't care whether you're a master or a BTech, but they don't, they take as a contractor with a 6 lakhs package. When you do well, then they regularize after a year. So, Synopsys and Cadence, all these packages are 12 to 14 lakhs if you get selected in Synopsys or Cadence, or even for that matter, Intel and all of this. But there is no guarantee when, the uh, uh, when they have extra requirement, they come to the any product companies or MNCs average will be 10 lakhs plus. You can with benefits it will go up to 16 lakhs also. In some cases, see, that depends on if you are from IIT or NIT, the salary will be much at a higher bracket. Okay, so now let me go to the question section. Somebody asked course fees, we have already clarified. Bhumika, let me share. Bhumika, okay. I'm interested in VLSI domain, but don't know much about programming language. So which sector should I use? So in case we do not like programming language, if you do not like the programming language, you can you can choose any of the physical design. You can choose design for test kind of options, not design verification, because that involves programming language. So DFT, that way, DFT can be considered as a front end. It is not a tool intensive. It is a tool intensive, but front end design for test is a better option. But if you don't like programming, yeah. Any other questions? If you don't have, so we answered Bhumika question. So offline, Kiran from HM, are there no offline classes? See, this course is particularly, our offline, see, with COVID, we stopped offline. With COVID, we stopped offline. We are starting offline classes again in July. All right. So we're starting in July, offline classes. So for now, the student courses, right? Let's say to people from, you're in different state, different cities, and pursuing BTech and MTech, there's, how do you do it? It has to be online only, because you are in a hometown, you are pursuing BTech or MTech. So these certification courses are online courses, while you continue your studies and get placed by the time you get your final, complete your BTech or MTech. That is the intention of those courses. But the offline courses are planning to start in July. Recording, we'll share the recording. It will be there for a month or so. Each topic recording will be there for at least a month, 1 or 2 months. But this is a general, right? But the next will be physical design, DFT, design verification webinars will be more technical. So there will be less of, there will be focus will be there, because now we have covered at a higher level. That will be more about what is DFT, what is physical design, what is design verification. Any other questions? Okay, so if you have in case any of you are, they need more details, our learning advisors, in case, it's okay. Whether you join or not, doesn't matter. But in case if you have more questions on the specializations or whatever, you can reach out to learning advisors. In case you are interested to attend any of our upcoming webinars, you can you enroll into the upcoming webinars on. I think I will share that. I think some of you have seen that upcoming webinars list. Please register there, and we will see you. And different speakers will come and present upcoming webinars. Week 7 days. Do we have 9 to 1 p.m. class? 7 days, right? If you have a 9 to 1 p.m. class, Shruti, you have a class. I mean, all students will have typically classwork during weekdays. Hence, we avoided classwork on weekdays 9 to 1. It's only there on Sundays only. So weekdays, it is not possible for current students who are pursuing the class. Okay, so Prasad, maybe with that, unless there is any questions, appreciate everyone taking the time to join. Hope we have clarified to some extent because of the time limitations. Please do join if you are particular about knowing little more thing. You can join our other webinars, upcoming webinars. In case any of you are interested in. I feel the market is still good. Market, I mean the VLSI demand, irrespective of the rational things, because the chips has to be, the chips always work at a few years ahead. Then people already, Qualcomm and all that might have already started working, doing some R&D work in 6G also. So the point is the electronics industry thinks much ahead and makes chips for the market or future needs. They cannot stop working. And so companies has to continue to innovate, and they will produce the chips so that strong visibility next 3-4 years, irrespective of that way. Thankful to compared to IT, this industry is positioned well for next 3-4 years. No problem on that. In general, it is a little stable industry, unlike the IT industry that way because of the demand. So okay. Prasad, shall we close and end the session?
Yeah. I'd like to thank everyone for joining us today, listening to us patiently, and I'm sure whatever Venkat communicated will definitely add value in making your career decisions much more better, is what the thought is. With those words, probably we can close today's session. Thank you so much, all. Thanks a lot for joining.
Thank you. So in the end, there could be some survey. Please do fill that survey so that we know what you are thinking, what you are, what one you are interested in, kind of. Okay. All the best for you. Doesn't matter whether you choose VLSI or not VLSI, where you join, but I try to throw some light on to the extent I think. Choose whatever is passionate to you. Whether it is VLSI. Particularly if you are VLSI, non-VLSI is also fine, embedded is fine, or But if you are in VLSI, choose your options carefully. If you are in a BTech, try if you can get a good MTech gate score, try for that. Obviously, there is nothing like doing MTech in IIT or NIT because that always carries a brand value. Assess yourself: can you get a good MTech score, or can you get into one of these premier institutes? If not NIT, IIT, NITs. Can you get into VIT? Can you get into BITS? Can you get into Manipal? Because this big, premier, or can you get into PSG? Can you get into at least locally some of the in Bangalore? If you are from Bangalore, BMS, PSIT, RV, MS Ramaya, Amrita. Can you get at least these two institutes? Not below that. Don't go below that. Below that, you will not get opportunities. Companies definitely comes to these colleges also. At least up to this level is okay, but not much below that, where it will be wastage of your 2 years. You will not learn anything and wastage of 2 years. So don't. I wouldn't recommend that. Either go to best institute or take a job-oriented course, VLSI course, get a job and settle. That's my sincere advice. Okay. With that, I wish you all the best for you for your career. Somebody posted one last question. MTech one last question. We'll take that question. MTech in colleges, like there are They're all product-based companies. Ken is good. As I said, I mean, I just answered that question just now. The every state, I mean, university colleges, etc. I mean, you will come to know you if you ask that college whether they which companies are visiting for placements. For you will come to know how many of the current students got placed in which company. You will come to know. So that should help you. With that, thank you and all the best for you for your career, whatever you do. But use your time well. I appreciate use your campus time well so that from campus you will land up to a trainee, land up to your job directly, which is ideal. Okay.
Thank you all for joining this webinar and making it a good success. I am sure each one of you have got valuable inputs to build your careers. And we also look forward for your presence in the upcoming webinars, which are more course specific or domain specific. Look forward to see you there. And we also have VLSI certification courses exclusively designed for students and freshers. And this also comes with the inbuilt internship, that is integrated internship. And for that, request you to reach out to our phone number, which is given in the website as well as in the slide here. That is 844-844-8839. Or you can also email me at prasad@chipage.com. And our office address is at 7th Sector HSR Layout, which is displaying on the screen. Please feel free to visit our office if you want to have any in-person consultations with us. Once again, thanking each one of you. Have a great evening and all the best to all of you.